I'll be honest, this question blew my mind. It's definitely a step up from the rest of them. We've got these three semicircles and we're trying to work out the shaded region. The key thing is that this is at an angle of 30 degrees. Now, when I did this, I spent too long trying to I called these individual names and then thought about adding and subtracting them to get some equations. But I've missed the fact that, we really need to focus on this 30 degrees. That is going to be absolutely essential. We know that the semicircles have area 24, and that's actually going to be pi r squared over 2. So we can go straight into working out this red region because that's 30 degrees. So actually it's a sixth of the semicircle, and therefore this red area is going to be 24 divided by 6. It's going to be 4. Okay, so I've worked out one of them. This is a good starting point. Okay, now for this region here, this is what you have to notice. We've got this green kind of it's like an upside down shield. I'm gonna move it over here. But actually there's another one here, and they're gonna be identical. How do we know that? Because the lengths are the same on both. They're both the radius of their respective semicircles. And if we join a line up like this, we can see it is the same. Okay, we can draw this triangle inside of each, and then the circle is just arcing around in both cases. So they are equal. Now for the green one, we've got this line going up like this, and we've got 4. But notice this black area on the green one, the black area here, is the same as the black area here. So because they must add up to the same area overall, we've actually found our second area. This is also equal to 4. Okay, so we're up to 8 in total. Now, it's not a bad shout at this point to think, you know what, maybe the other one's 8 as well. I'm going to go with 12, and you would be correct. Okay, it's not like that's not properly completing the question, but in terms of SMC, you're running out of time. If you did show that was true, it's not a bad idea to go for it. They kind of look similar, don't they? So just to recap, we've worked out the sector area. We've related it to 24. Yes, sorry. So we saw, yeah, we saw that it was 24 over 6 because we've got a sixth of the semicircle, so that's how we got that 4. And then it's tough to see, but this green kind of upside down shield and the purple one, they are identical, but they share this black area that I've highlighted. So it must be therefore that the the shaded area inside the purple one that's not black is also 4. Okay, on to the finale, and I've got to be honest, I could have stared at this for hours and I would not have seen it. So well done if you managed it. Okay, assuming otherwise you're here because you also struggled with it. We've got 4 and 4. Now we will somehow want to get this involved, this area involved. Okay, let's look into it. It's hard to really know where you'd even come up with this next idea. But what we could do is create a sector. We could join that line up from Y to this point. We've got an isosceles triangle here because these two are the same. So that will be 30, which means we know this angle is going to be 120 degrees. So if I focus on this, I called it was a black area before, I'm now going to call it X, and this is going to be A, then I can say that X plus A is the entire sector, and we already showed that the 30-degree sector was 4, so this is going to be 4 times as much. It's going to be 16. But then I'm going to need to minus the area of this isosceles triangle. But note, this isosceles triangle can actually be turned into an equilateral triangle. So I've got my sector. And if I kind of bring this one round, it's going to end up having 60, 60, and 60. I'm sort of saying that I draw it, not like that. I draw it, I get rid of this and move it here to create that equilateral triangle. So just going to actually highlight this. X plus A, and that's what I want to find. I want to find A is equal to 16 plus minus an equilateral triangle. Okay, let's try and bring in one of the other areas that we actually know. We're going to return to the upside down shield. So now I've got 4 and I've got x. So x plus 4 is going to equal this upside down shield. But here's the thing, is at the point, if I join it up, I actually create an equilateral triangle, the same equilateral triangle that we had a minute ago. This is going to be 60 degrees. And I can find this area in terms of the equilateral triangle anyway, by looking at the sector on the left. That's going to be this bit here. And it's going to have an angle of 60. So it's going to have size 8 because it's just double the 30 or half the 121. Then I can find the area of this sector going in the opposite direction. Again, 60 is going to have an area of 8. So what I've done is I found this area in green. I found this area in red. I've double counted the inside. I need to minus an equilateral triangle with lengths of r. So bringing this together, we have that x plus a is equal to 16 minus equilateral triangle. We have x plus 4 equals 16 minus an equilateral triangle. And the only conclusion is therefore that a is also equal to 4. We don't have to work out x, but we can show that a is 4. Whew, we're there. So this one was not too bad to find. That was a long time ago now, but that was 4. This was a nice argument below to show that that area is 4. This one is so much more involved, but we can actually show that it must also equal 4, giving us our final answer of 12. Very well done on this math challenge, and I hope you enjoyed it. Keep practicing maths, and yeah, good luck with it.